Hello, today we're going to talk about the reaction of alcohols. Before we start talking about the actual reactions of alcohols, we should actually establish what a primary, secondary and tertiary alcohol actually are. Alright, so primary alcohol is the alcohol functional group, so this OH here is attached to one carbon that is attached to one other carbon. Alright, so in other words, we start off and we find the alcohol functional group, the OH group. Okay, you can see the OH group is here. And we find the carbon that OH group is attached to, this one here, and this carbon is attached to one other carbon. Alright, so that's what makes it a primary alcohol. In this case, we have 1, 2, 3 carbons. So this is going to be propane 1-ol, because that alcohol group is on the first carbon. Alright, so this one here is propane 1-ol. Alright, now let's talk about secondary alcohols. Just have a look at the secondary alcohol now. So we can see that the main difference between the primary alcohol and the secondary alcohol is the position of this hydroxy group here. So the OH group on the primary is on the first carbon. Okay, in secondary alcohol, the OH group is on the second carbon. Alright, so that's going to change the name from propane 1-ol to propane 2-ol, and that's also what makes it a secondary alcohol. So the definition of a secondary alcohol is the carbon attached to the hydroxy group is attached to two other carbons. Alright, so same process before, we find the hydroxy group, we go down to that carbon, and this carbon is attached to 1, 2 other carbons, therefore it's a secondary alcohol. Okay, now let's talk about tertiary alcohols. Alright, so now let's have a look at this tertiary alcohol. Alright, so we can see that we have that hydroxy group on the second carbon here again. Alright, so the only difference from this tertiary alcohol to the secondary alcohol is we have a extra methyl group coming off that middle carbon there. Alright, so that's going to change the name from propane 2-ol to 2-methyl propane 2-ol. Okay. Now what makes it a tertiary alcohol is the carbon is attached to the hydroxy group is attached to 1, 2, 3 other carbons. Alright, that's what makes it a tertiary alcohol. So to recap, primary alcohol, the carbon attached to the hydroxy group is attached to one other carbon. Alright, so we go down, this carbon, one other carbon. Secondary alcohols, this carbon is attached to two other carbons. This one here, this carbon is attached to 1, 2, 3 other carbons. So that's the difference between primary, secondary and tertiary alcohols. Now let's have a look at the oxidation of primary and secondary alcohols. So in Unit 3, you were taught that oxidation is the loss of electrons and reduction is the gain of electrons. That is true, but oxidation can also be a few other things, and reduction can be a few other things. So oxidation, it kind of gives it away in the name. It can be the addition or the gaining of oxygen. Okay, so oxidation can mean the gaining of oxygen, also the loss of hydrogen, or the loss of electrons. So they're all the different things that oxidation can be. So I'm going to write that here. Alright, let's have a look at this now. So we've got the primary alcohol up here. This is what we started off with, right? We started off with propane 1-ol, so the primary alcohol, because hydroxy group's on the last carbon here. Alright, and then from here, the first oxidation goes from an alcohol to an aldehyde. Okay, so if we look at this molecule and we compare it to our original alcohol, the only difference is we don't have a hydrogen on this bond here anymore. Instead, we have a double bonded oxygen to the carbon. And because that's on the last carbon, this molecule goes from an alcohol to an aldehyde. Okay, but from here, it's then oxidized again, and it has gained oxygen onto that last carbon. So you can see here, this part stays the same. The part that changes on the functional group side is it goes from an aldehyde functional group to a carboxylic functional group. Alright, so it's now an acid. So it goes from an alcohol to an aldehyde to a carboxylic acid, and that is the oxidation reaction pathway for a primary alcohol. Alright, it's going to be a little bit different for a secondary alcohol. So let's have a look at the secondary alcohol oxidation pathway now. So now we're looking at the oxidation of a secondary alcohol. Right, so essentially it is a similar idea. So we still have the loss of hydrogen on that first step. Okay, so the difference between here and here, the functional group has changed. So we no longer have a alcohol functional group here. Instead, we have the double bond to oxygen, and because that's on the middle carbon, it becomes a ketone. All right, so we go from a alcohol to a ketone. In this case, we went from propan-2-ol to propanone. All right, and that is the last step. So you can't oxidize a secondary alcohol any further than the ketone. All right, with a primary alcohol, we could go all the way to a carboxylic acid, but in this case, the furthest you can go is just to a ketone. All right, now with a tertiary alcohol, you cannot oxidize a tertiary alcohol. Alright, so you never have a question asking you to explain the oxidation of a tertiary alcohol, because it just can't be done. Alright? Okay, cool. That's pretty much everything to do with oxidation of alcohols. Hopefully that makes a bit more sense. Okay, one more thing I wanted to talk about is these two molecules here. Alright? So in your exam, if you see either potassium permanganate or sodium dichromate in the question, so you might be given a chemical equation, and these two molecules might be used as a catalyst. Okay, so an example question could be something like this. So you're given substance A plus B produces C plus D. Okay, and then if you're told that there is potassium permanganate as a catalyst, and that can give you a clue to say that it's a oxidation of either primary or secondary alcohol. Okay, so if you see either one of these molecules here being used as a catalyst, that's kind of a clue that the question could be talking about oxidation of alcohols.